In this video, we'll discuss level curves. What are they, how do we find them, and what do they look like? We'll start with the definition. A level curve of f of xy is the set of points in the xy plane satisfying f of xy equals c for some constant value c. So f of xy is a three-dimensional function with x, y, and z values. The level curve replaces z with a constant, meaning that the level curves will only have x and y variables. So level curves are in the xy plane. Here's an example of a function and some of its level curves. The surface z equals f of xy equals 100 minus x squared minus y squared is the graph of f. This is an upside down paraboloid with z-intercept 0, 0, 100. The figure shows several level curves in the xy plane. For example, let's look at the level curve for c equals 75. This would give the equation 100 minus x squared minus y squared equals 75. We just replaced z with the constant value. Now we get it into a form that we recognize. Let's add the squared variables to both sides and subtract 75 from both sides. So we get 25 equals x squared plus y squared. Now we know that this is the equation for a circle of radius 5. This gets graphed down in the xy plane. We can do this for any real number c value, so any surface has infinitely many level curves. Here's our first example. Describe the set of all level curves of z equals f of xy equals the square root of x squared plus y squared minus 4. So recall that a level curve is f of xy equals c, where c is an arbitrary constant. This would translate to the square root of x squared plus y squared minus 4 equals c. Notice that since c is equal to a square root function, c must be non-negative. Now to get rid of the square root, let's square both sides. This would give us x squared plus y squared minus 4 equals c squared. Add 4 to both sides, and we get x squared plus y squared equals 4 plus c squared. Since c squared is non-negative, the description would be circles of radius 2 and larger. So we've just described the set of all level curves of the function we were given. Any circle of radius 2 and larger. In the next example, we'll look at specific level curves by picking specific values for c. We are asked to find and sketch the level curves of z equals f of xy equals the natural log of 1 minus x squared plus y for c values -1, 0, and 1. I'll start by getting my xy grid ready. Now, let's start with c equals -1. Remember, the c value replaces z, so this gives us natural log of 1 minus x squared plus y equals -1. Now, how do I get rid of the natural log? If you think back to algebra, you might remember that e to the x and natural log of x are inverse functions. So I'm going to apply e to both sides of the equation which will cancel out the natural log. So we get 1 minus x squared plus y equals e to the negative 1. Using rules of exponents, we know that e to the negative 1 is 1 over e. Now isolate the y variable and we get y equals x squared plus 1 over e minus 1. We want to graph this, so let's get a numerical approximation for 1 over e minus 1. So y equals x squared minus 0.63. I'll label the x and y axes on the grid. And I know that y equals x squared minus 0.63 is a parabola with y-intercept negative 0.63. Then you can plug in other x values to get more points. And there's our level curve for c equals negative 1. Now let's do the same thing for c equals 0. Replace z with 0, and we have natural log of 1 minus x squared plus y equals 0. Let's apply e to both sides. So 1 minus x squared plus y equals e to the 0, which we know is 1. Solve for y, and we get y equals x squared. So the graph is the basic parabola of y equals x squared. Now we need to do the math one last time for c equals 1. So we get natural log of 1 minus x squared plus y equals 1. Apply e to both sides to get rid of the natural log. We get 1 minus x squared plus y equals e to the 1. So y equals x squared plus e minus 1, which simplifies to y equals x squared plus 1.72. So we get a parabola with y-intercept 1.72. And that gives us an idea of the typical level curves for the function z equals natural log of 1 minus x squared plus y. This last example is a little different because it gives us a point instead of a constant value. We are asked to find an equation for the level curve of the function f of xy equals 2y minus x over x plus y plus 1 that passes through the point 1, negative 1. So first, we want to find the constant c by plugging the point into f. We get f of negative 1, 1 equals 2 times 1 minus negative 1 over negative 1 plus 1 plus 1. So I've just plugged the x and y values into the appropriate place in my function. This simplifies to 3. Now, recall that the level curve of f of xy equals c. So we get 2y minus x over x plus y plus 1 equals 3. Now we want to simplify, so we get 2y minus x equals 3x plus 3y plus 3. I got this by multiplying both sides by the denominator. Now move all y's to the left side and everything else to the right side, and we get negative y equals 4x plus 3. So y equals negative 4x minus 3. And that is my final answer. Now, just to note that Wolfram Alpha is particularly good at showing level curves, also known as contour lines, for 3D graphs. Try going to www.wolframalpha.com and type in plot z equals open parentheses xy, another open parentheses, x caret 2 minus y caret 2, close parentheses, over open parentheses, x caret 2 plus y caret 2, close parentheses. When you get the graph, click on the Show Contour Lines button and it will display several level curves of the function. Try this with other functions too. So remember, level curves take a three-dimensional function, replace z with a constant, and then look at the equations and graphs in the xy plane, and those are your level curves.